Good morning, everybody. Appreciate you taking the time to join us here so early on a Thursday morning. I'm Derek Burby. I'm the regional manager for Franklin Electric. I've got Charlie Fox, who handles the sales for the western half of Montana. Many of you know him, and I also have Phil Alberto Zueta, who's the product manager for package systems, which is what this booster pump falls under. If you guys have questions along the way, feel free to ask those questions either unpause yourself, or unmute yourself, or type it in the chat, and we'll make sure we get those answered. We want to make sure we get all your questions answered here this morning on our inline controls and our booster products. So with that, Philly, I'll turn it over to you.
Thanks, Derek. As Derek mentioned, we'll try to cover some of the questions along the way, and then if there are any pending, just type them in or send them to Charlie or Derek, and we'll address them. So we'll get going. I hope everybody can hear me, and we'll get going. We'll start talking about inline controls. Then I'm going to transition a little bit to the combo products, what we call a combo, which means an inline control along with a choice of centrifugal pumps, surface pumps. And then at the end, if we have enough time, I also want to bring up a couple of other alternatives when it comes to I will call it residential or light commercial boosting applications. So with that being said, we're talking about systems that typically go into a residential setting where we're getting our water source and trying to replace a traditional system with a differential pressure switch. There are solutions today and have been for years that will accommodate these applications and at the same time provide a little bit more of space savings when it comes to certain sites. It will also help with pump protection, and it will also reduce the number of components that we're needing to add to that pump. If I wanted to put inline controls into a map of alternatives, this will be more of a solution that is going to be kind of in the middle of the road between a conventional pump with a pressure switch and a bladder tank and a VFD that provides constant pressure. The inline controls have or use a microprocessor and then signals depending on the model, but most of them use both a flow signal and a pressure signal to decide when to start the pump, when to stop the pump, and when we have a potential issue with the water source, which could be causing the pump to run dry, or to say, hey, we're cycling, or to say, hey, we haven't started this pump in a long time. Why don't we give it a spin so we prevent it from locking up from debris or just the components of the pump getting stuck. So these controls are in reality nothing new for the world. In the U.S., they're becoming more and more popular because they give a good price point with additional protections to just the standard system. So just to give an example for the opportunity for these advanced controls is right into just even providing protection BT4 pumps, as I mentioned, while keeping an affordable price for those customers that are not willing to pay a constant pressure system. So you can see here some examples of the controls that we carry, and you can tell, 151 of the list price. It's considerably less than a BFD, but it is not that much more than what you will spend on a traditional system. And then there are some other benefits or savings that you will see when it comes to most of the applications. So what we're talking about is going from a installation that will definitely require more space. In many cases, will require to add components like isolation valves for the tank or the bladder tank. In some of our controls, we have an integrated gauge, so you would have to plumb that additionally. And then, obviously, the simple, more simple plumbing. So we have certain examples, and you can see the pump to the very right is a BT4 pump, one of the pumps that we carry that could easily be used on a car washing application where you want to boost the water, but you really just want to immediately start the pump based on the flow. So as soon as you get that demand, you're using a simple flow control to get the pump going. Or in some instances, we've seen these BT4 pumps with the FLW control that are used on RO systems, and kind of going in the same direction of, we're not that concerned with the pressure, because the pressure varies as the filters get clogged or the filters go through their life. But you want to make sure that you always keep that pump running as soon as there any water demand. And I'll explain the differences on the different controls. There's 5 different models, but in reality, three different functionalities. So I'll go through those. Before I go into detail, I do want to lay out what is the offer. Like I said before, we have 5 different models, but I can put these 5 models into 3 buckets. The first one being the FLW, which is entirely flow-based control. So as soon as, like I mentioned before, as soon as there's water demand, the pump will kick on. It will have all the same protections as the other controls, but it will be a purely flow-based operation. Now, the SWC, SWP, and the adjustable, those are the controls that now combine the flow, the flow demand, and a pressure setting. In other words, if I had an application where there's not a definite flow demand, but maybe the pressure or the water starts being used to a point where the pressure drops, these controls will also have a low pressure threshold, similar to a conventional pressure switch, where it will tell the pump, hey, we need to start. We're getting a very low flow demand, but the pressure has dropped to this point where we need to kick on to prevent the pressure from dropping further. And then finally, the CTL, it's maybe another in its own category, in the way that the CTL helps to control the pressure going out to a house or an application or building, where we could have a pump that generates too much pressure, and this will be a smart replacement to a pressure reducing valve or a PRV. So the functionality, one of the reasons this controls work so well is that they're very simple in design. I don't want to get into a lot of the details of how this operates, but in essence, you have a piston that if you look at that little yellow square, that piston contains a magnet, and depending on the position of the magnet, we can tell whether water is flowing to the system, to the demand, or if there's no demand. So they have a very low threshold. As soon as the magnet moves at a certain flow rate, we can tell when somebody has opened a faucet or a tap. And then similarly, we have some magnets across the shaft that is being pushed by this spring that can be adjusted to a certain pressure set point. And based on that position of those magnets, we can tell, hey, we are at this pressure, or we need to, we can decide then when we need to kick on the pump. So going in, a little bit more into the specs of each one of the models, the FLW, our flow-based control, will start the pump at a 1/4 gallon per minute or more. Like I mentioned before, this is what you will typically see on booster applications, BT4s, MH pumps. Typically, whenever you want to control based on flow, like those RO systems I mentioned before, and watch down applications.
You're right. 2 years ago was probably the best winter I had out here. Like, I've been out here for just about 7 years, and like my first winter was like, it's hard to say like if it was good or bad, because I was just like blown away by everything out here, man. Like, because I've been skiing on the East Coast, so I just lost my mind that first winter. But yeah, 2 years ago that winter was dope. And hopefully we have another good one.
Yeah. Last winter sucked. Where are you from originally?
Virginia?
Virginia.
Yes, sir.
What brought you out here?
Okay, so the SWC, on this one, going back to the previous comment, on this one, another of the benefits, and similar to the FLW, we have the flow control, but also the pressure setting. I also want to mention most of these controls will operate both on 115 and 230 volts. So in this particular case, the SWC is one of the controls that may probably applies to most of the surface pumps that I see out there, just because of the pressure set points that they come preset at. In this case, the SWC will basically replace a 20/40 pressure switch, or that's where you will use it to say, hey, if the pressure drops to 22 psi, or the water demand is more than a 1/4 gallon per minute, we need to get this pump going and get ahead of the game on the pump curve, and make sure that they see as little change in the pressure at the point of use as possible. The SWT, this model will be basically a brother, if you will, to the SWC. They have the same functionality, operates at or kicks on the pump at 22 psi, 1/4 gallon per minute flow or more. The only difference is really just the size of the connections. So this one comes with an 1.25 inch thread, and it will also be the maximum amp rating. So you have a maximum of 20 amps. So you can tell 20 amps at 230 volts, you're easily talking about a 2 horsepower pump or even a 3 horsepower pump. So these two go side by side. They have distinct functionalities, just depending on how much water you're planning to move or how big that pump is. One might be more convenient than the other. On the adjustable, this work very similar to the SWC. They have a threshold of 1/4 gallon per minute to kick the pump on. But the main difference is that with the adjustable, you have a very simple set button on the front of the control to adjust what you want this kick on pressure to be set at. So it can be selected to be 22, 29, or 36 psi. In any case, regardless of what's your kick on pressure, we're expecting the pump to make at least 20 psi above that threshold or that kick on pressure to make sure that the system operates and starts and stops consistently, and just like you will see it in any other standard system with a bladder tank and a pressure switch. And then finally, the CTL. Like I mentioned before, the CTL is a little bit different from the rest in that this is really to hold and a little bit control when you have excessive pressure. So this is, particularly seen when you have a submersible application, which, by the way, all of the other controls can also be used with submersible pumps. But in this case, the CTL really comes handy when you might have a low static level on your well, and then that static level is dropping once the pump is running. So which means that you will have a lot of pressure from the get-go when you're starting the pump, and that pressure is going to go down as the level drops on the well. So this CTL really helps in that controls or contains that pressure to an adjustable pressure setting. So you can decide anywhere from 50 to 94 psi. What is the pressure that you want on the outlet of the control? Again, can be used for surface pumps, but for the most part, we see this going with submersibles. The typical installation is really easy with these controls. One of the things that you probably noticed already is that we recommend, or we recommend for the most part that you don't even have a bladder tank with these systems. And the reason being is the control will act as that protection to avoid cycling of the pump in excess, and it will also get ahead of the game instead of waiting for the water to be completely depleted. So it will get ahead on the game into maintaining a pseudo constant pressure. The pump will keep running at full speed, but we're definitely knowing in advance when the pump might need to start when you have a water demand. One thing to keep in mind, and this is maybe one of the only requirements, but I don't think that you'll see any issues with this, is that the pump, whatever pump you decide to put with the controls, must generate at least 20 psi above the system set regulation pressure. So in other words, if you want the pump with an SWC to kick on at 20 psi, you want to make sure that that pump can make 42 psi, which, you know, in the most of the cases that will hold true. The electrical installation is also pretty easy. You basically have your 115 or 230 volt power coming into the control, and the control will act as that starting relay to kick on the motor as needed. These are some typical applications. Here I'm showing two sides. That one on the left is an RO system, and you will notice that they have a SubDrive utility there, one of our VFDs as well. And on this RO system, basically they had a series of pumps that are providing water from a well, and then once it gets into the RO system, it goes through another set of pumps. So what was interesting about this site is that not only they had a VFD to regulate the pressure, they also had one of the controls to operate one of the pumps that they had internally in this RO system. The picture on the right is a residential application in the Northeast. You will see that in this case, they had kind of a complicated system in the sense that they had a water well, and they were using one of our CTL controls to regulate that pressure that came from the well. Again, one of those instances where your static level was really high, but there was a lot of drawdown. So at startup, they wanted to contain or regulate that pressure. So the well was providing that water to a tank, and then from the tank, they were using another control that you might see close to the floor there. And that other control was actually operating a second pump that was regulating the pressure going into the house after it went through some treatment. So again, two controls, one for submersible, one for a surface pump. In this case, the same. They were even using the same control, but you know, two different pumps. But it talks about the versatility of these controls. We have seen from some markets the need of having these controls built into the pumps and have them as a single unit. So we launched this year what we call a control package, which is an SWC control with a choice of MH pumps and VersaJet pumps that I think Derek had one of them there at the office. We have 4 different models. All of these are on a 115 volt plug. Technically, I mean, if you wanted to run it at 230, you could still do that if you wanted to. But we have gone through the testing and the UL approvals to have that 115 volt plug. So these are really a pretty convenient solution, if you will, for those customers that want to spend as little time as possible on site. And I will think that most of your plumbing contractors are going to be in that that area where they want something that they can probably just plug into an outlet, get the plumbing done, and get out. So this will be a pretty pretty good solution to that. Showing here some of the list pricing and for the 4 models. I think that with the combination of the VersaJet and the MH, you could be covering quite a bit of applications, or I will say maybe the most common applications, 1/2 and 3/4 horsepower. We also have a resource that helps you kind of size these controls. We will we'll make sure Derek or myself or Charlie will send you the PDFs on this, or we can get you some physical copies. But basically, this charts help you very easily say, hey, you know, I have this pump that is a 3/4 230 volts. What controls can I use with this pump? And so we made a chart with all of the Franklin Electric pumps, all of the surface pumps, I will say, that are most commonly sold, and some of the submersible pumps as well, where you can tell just by the part number what are the many options that you have for these controls. And I think that that will also make it easy if you're retrofitting an existing application. Maybe you can you want to get rid of the bladder tank, you want to put one of these controls, you can do that pretty easily. For the control packages, we also have a spec sheet showing all the dimensions, the part numbers, and what are the choices there. And finally, I want to show a video here, and hopefully this will open and transition. Let me know if you cannot see the video for some reason. I think I got it now. Okay, I think that it was a little bit hard to hear the sound from the video, but that's as far as my computer speakers will go. So I'm hoping that this, brings some some ideas on how we can use this controls, and you'll see that there are many applications where we will easily upsell to what a conventional system is. One of the things that I see a lot of times is that we use tanks when we're shipping out to customers, and those are probably the components or the parts that take the most space, but not necessarily where we're making the biggest sales. So on small applications, in this case up to 2-3 horsepower, I think that the controls are going to come really handy for making the case that to the customer that they can definitely upsell to theirs if that homeowner wants to have a little bit more protection without going all the way into providing a BFD or some other electronic protection. So with that being said, I wanted to show a couple more slides that are not directly related to our inline controls, but they are some alternatives to boosting applications.
Hey, Philly, we have one question here in our room.
Sure.
So with the 3/4 horse VersaJet with the SWC, works in a pressure boosting application, correct?
Correct.
Okay, so if we have, say, 35 psi incoming low city water pressure, and we want to boost the pressure to 60, 65 pounds, I guess what can I expect this pump to do at, say, 10 gallon a minute versus our shutoff pressure? Is it gonna boost that shutoff pressure 40 pounds from the incoming pressure?
That is correct. So if you have a certain incoming pressure, you'll just simply add that to what you will see on your curve of the standard VersaJet. So if you look at the curve of the standard VersaJet, it's not going to be any different from that. At least not that shutoff. Now, keep in mind, if we're talking about the SWC control, you are looking into that 22 psi setting. So it will only kick on if your pressure out to the surface drops to 22 psi or less, or if it detects a water demand of more than 1/4 gallon per minute. So with that, what I'm trying to say is that even if the pressure was higher, but you detect that you're moving water at a higher rate, then you will see the pump kicking on.
Okay, and that's what I would expect to see. Say with a varying inlet pressure, say it's sometimes at 50 psi or 55 psi. So in that case, we got 55 pounds coming in when no one else in the subdivision is using water, so the pressure is a little bit higher. So the pump kicks on based on demand, because there's a demand more than 1/4 gallon a minute. Is the pump going to shut off at a pressure that's going to exceed the recommended pressure for the plumbing? Say we get up around 80 pounds. Is that possible?
It is possible.
Okay.
It is possible because it is looking at one or the other. It's
right.
not looking at both at the same time. So it's saying, okay, I'm being told that I want to run based on flow, so I'm going to kick it on. If you see that there's an application where there's too much variance, but you have at least 50 psi coming in, and we see this from places where the pump might not be next to the home, but maybe the pump is closer to the the lot, and then the house is maybe a few yards down or in an uphill or something like that. So you really want to have a certain pressure here. You usually want to say, hey, I want 70 psi or 60 psi, because now up there at the house, I'm only going to see like 40 or 50. If that's the case, and you see too much variance in that incoming pressure, then your best alternative might be a CTL, because the CTL will regulate the pressure. Will say, oh, I have too much pressure, but that CTL needs to have at least 50 psi income.
Right. So what about the ADG? I think it was the ADG model or ADJ model.
The adjustable, you can decide where to set your kick on pressure. But again, the pump will keep running.
That's just kick on.
The pump will keep running as long as you have water demand.
Okay. So it doesn't do anything on the shut off side. It's just the bottom side, the turn on side.
Correct. Yes.
Okay. So one other question on the MH series pump is not self-priming, correct?
Correct.
Okay. So are you familiar with the Grundfos Scala or the MQ?
Mm-hmm. Yes.
So the MQ operates a lot like the SWC, I think. Would you agree? I mean, as far as flow, as far as control and shut off and.
Yes, it does too. You're talking about the MQ or the Scala?
Well, the MQ is based on flow primarily. There's no pressure adjustments with the Scala 2. You have a pressure setting. You can tell the pump to shut off at a certain pressure or maintain a certain pressure, basically.
Yes. Now, keep in mind the Scala, I believe it's a BFD, so
right.
the price point will be considerably different.
The what did you say?
The price point.
Yeah, right, yep.
So, and that's why I wanted to just add this couple of slides at the end. We do have the SubDrive utility, which could serve that purpose if you want to have more of a constant pressure. But you're not talking about a $150 list on a control. You're talking about a $900, which is still pretty competitive to any drive that you will see out there. So with the SubDrive utility, you can still cover really any of the surface pumps up to 1.5 horse up to 30 volts. So the SubDrive utility, it's one of those drives that I also feel that have a lot of flexibility, from the standpoint that if you are if you're in a region where 2-wire submersible motors are popular, then you have a drive on your shelf that can operate both a submersible but also a surface pump. So as long as you have any of those two, you can still use that drive and provide constant pressure. So that could be another alternative. And I mean, it all depends what type of customer you're talking about. And in reality here, what we want to provide is a menu. we want to provide the appetizers, the salad, but also the steak. I don't know if there are any questions. We still have a little bit of time, and if there are no questions, I want to share one more thing here real quick. Hoping that you can still see my screen. What I'm showing here is the Inline SpecPAK. This is more on the commercial side. What you will see on, clinics or restaurants, what you will see is small hotels, that sort of applications. If someone can confirm that you're still seeing the presentation, we have
We can see it.
a range there. Okay. We have a pretty good range of the systems going from the, duplex all the way to the quad, where we provide a very flexible system that is wall hung and that provides constant pressure through, depending on the model, can be an alternator or a PLC. And if you have some of those plumbing contractors that are going more into the retail or commercial space, I think that this will be something that they want to consider. I've seen them in numerous places from the West Coast to the East Coast, and we always hear good comments about how this system is saving them space and making it very simple to plumbing and plumb out. You will see that we have Victaulic connections there, so you can flip your incoming the pipe where you're coming in with your water supply, or the upper manifold. You can also flip where you have your bladder tank easily. So this is another product that was recently added to the Franklin Water webpage. So if you want more information on this, there I can provide that as well. But we're relying on the Inline 1100 booster pump with a VFD that I think that you are already familiar with. So we're basically setting up just a system that is preset to alternate more than 2 pumps. So with that being said, I don't know if there are any other questions, comments.
Can you use this on anybody's phone?
Mhm.
Yep.
So the thing that I noticed that where this won't work on that pump is the discharge size. 1.25 inches versus 1 inch. I'm sure you could put a bell reducer on there and make it work, but you guys don't offer that pump with this controller in a box, already wired.
No, the only current option is the SHC complete with the first gen of that. But you, like I said, you can take that and put on any of those, put them on our pump.
Yeah, this would be great for irrigation, for a lawn sprinkler pump.
So on the submersible, you would just tie the power into the, before it goes down to the,
Just run it through here.
through
Just like
this
this.
and then down to the pump, and you wouldn't need a bladder tank or a pressure switch or.
That's right, Philly? All that would be incorporated in the switch, correct? Whether we're using the CTL or.
Yes.
So
Yeah, so if you want to think about it, it will be like having your pressure switch, but it's going to go on the main line.
So how do you get your runtime out of a submersible with this control on it?
I'm sorry, I was hearing something.
So if you have
What was
this,
that?
if you have the CTL on a submersible application, the pump is still running full speed. How do you get your runtime out of your submersible pump for the cooling and?
Well, the CTL is intended to work more as a PRV valve. So you're in a way you're keeping that pump running when you have excess pressure. So in most instances, you'll be running more than the 30 seconds that you'll typically need.
Okay. One I noticed too when we had this one hooked up on the bench that it wouldn't short cycle. It seemed like when you closed the valve, it would run for 20, 30 seconds before it actually shut off. So.
Yeah, one thing that you want to make sure, especially on the CTL, because I guess the minimum that you can set your pressure to is 50 pounds regulating, but it is expecting the pressure to reach 70, so you don't have that cycling issue. So if the pump is relatively small, let's say, I don't know, maybe a half horsepower, or a pump with a higher flow but doesn't make enough head to get to 70, then that could cause cycling for sure.
That makes sense.
So this works off the flow or the pressure? Both?
Yeah, and we do have one that's strictly flow related, so I guess it would depend on the application that we have.
So like if the guy's got his well here and it comes into the house and he's got several hydrants before it hits the house, is that thing gonna, if he's using that out there, is that gonna sense it wouldn't see the flow, but it would see the pressure flow?
Right. Your control.
Yeah, so
Go ahead, Phil.
if you have multiple taps, and yes, if you have one that is demanding more than a 1/4 gallon per minute, that will kick on the pump, but the CTL will artificially generate that additional head, so it will still control the pressure even though there's not a big demand, because you're using very little water, but you're at the same time getting the pump running. Then that's where the functionality of as a PRV valve or as a PRV valve it kicks in. It just generating that, or artificially generating that extra head, so the pressure going out to the house doesn't go too high.
But if you did have a hydrant between your wellhead and where the control was, say in the house, you had a hydrant between there, that probably wouldn't work, would it?
Right. Right, because the hydrant will be demanded water, but then you're draining the water from the control,
Right.
and so it wouldn't detect that you're moving that internal piston. That is correct.
Cool. Well, thank you.
Any other
Okay.
questions from anybody online?
And then items.
So you can't have anything between this and
Typically, yeah, and they ask that you do that too on VFDs, but you could take like the SubDrive 2-wire and you could wire that and see a little bit.
It's based on pressure.
That's no pressure case.
Hey, Philly.
Yes.
Charlie here. Could you address just quickly, because in some cases where we might be using a self primer with an inline control, and say we're not feeding it with clean water, maybe we're pulling surface water out of a irrigation ditch. Any concerns with the control when we do that?
It all depends on the site. If you're talking about solids, there could be the possibility to there's a little internal check valve there, Charlie, and so you might be. I mean, there's some tolerance to it, but I don't know how big we're talking about there on the solid size. But that could be something that holds the check valve open. And again, the only concern there is that you're going to drain the water out if you don't have another check valve.
Most of the time, I'm just talking particularly about a little bit of silt, some sand. A lot of these are filtered pretty well, so that say tumbleweeds and other larger debris like that shouldn't be an issue. But definitely some sand and maybe some silt coming through it.
Okay. I can double check what's the limit on the solid handling. I'm trying to show there on the screen that bottom black part that you see there is the internal check valve. So the only concern that I will have is that you hold that open with sand or something and it's just draining all the water out. But let me double check what will be the maximum tolerance for solids to go through it.
Thank you. Yeah, the reason for my question was we have put a few and have not had issues, but that question and concern, of course, has came up.
Okay.
Thank you, Philly.
Great question. Thanks.
So for the guys in the branches, looks like JJ and John, Reno, you guys are still there. The picture on top is the pump that we have set up for stock status in category 593. It's the 3/4 horse shallow well jet pump with the excuse me, SWC controller on it. And this would be almost a direct replacement for the MQ pump. I mean, the Sculla pump is still going to offer a little more advantages, I guess, just being a true variable speed pump. Although I think 90% of our booster pump sales, the MQ would work just fine. One thing we got to be concerned about is overpressurizing systems, as we were with the MQ, not so much with the Sculla pump. The price point on this pump is, I don't know, probably 3/4 the price of the MQ or the Sculla pump, maybe even a little bit better than that. I see we have a couple ordered going into Butte. I don't know, they've been on order since July. Derek, do you know why things aren't here? But anyhow, we do have the number set up. There's no replaced by for the MQ at this point, but just know that they're available or will become available as soon as these show up. But I guess we'll stick them in the branches that are interested in offering them as an alternative pump to the MQ or the Scala pump. Any questions?
Blake, this is Charlie Fox. I don't have a question other than who do you want me to send? I'm going to check that order for Butte and find out what's going on there. Who do you want me to communicate with and send that to when I find out when those are going to show up?
Charlie, you can send it to Scott. You want the PO number?
Perfect. Yes, please.
It's 323-9299.
I'm on it.
Okay.
Thank you.
Billy, can you see that question there or from John?
At least one jar hydrant.
We were talking just a second.
The only way to make it work is if the control is before the hydrant. So if you had a way to have the control before the hydrant, it will work. But if it's past the hydrant, it wouldn't work.
No, that's not so good up here.
Yeah.
Well,
These are outdoor rated too, so they wouldn't be a concern if you had to have them on the outdoors.
All right.
We could look at that 2-wire utility or as an option as well, John, for your area.
there's a lot of instances where, people put in a well, they'll put a yard hydrant right outside the well. I mean, there's obviously.
Yeah, they do that almost every time here.
Right. And this just isn't the control for that actual setup, but I think it's going to work really good for centrifugal, primarily the centrifugal options with, lawn irrigation pumps, booster pumps, even a shallow well application with this pump here that we set up. I think it'll work really well in that application. And probably most of the submersible applications, it's probably not the ideal fit, but there again, some of them it may work just fine. Cistern applications, it could work good for cistern applications. We've got suction lift with this pump. Be a great alternative to what we've, to a shallow well jet with a pressure tank or even the MQ or the Scala.
If you had yard hydrants on there and they didn't really care if it, if it worked on the hydrants, is it adversely going to affect the boost into the house?
It's not even going to sense it, right?
Are you asking, will they see a pressure drop at the house if they turn the water on?
Yes.
I mean, will they still work with the system with hydrants?
Downstream from the pump?
Correct.
Yeah.
Okay.
Your water hydrant will just be another point of use. Yep.
Okay.
Hydrant's not going to turn the pump on.
No. If it's downstream.
Well, if it's.
Yeah, downstream, but
That's.
yeah, but it's downstream. I would think it'd be fine. But
That's not going to work.
yeah.
Yeah, so if the demand is on the inside or the inlet side of the control, the thing there is that this little check will close and they will drain the pipe, but the controller wouldn't realize there's no incoming water to it or there's no demand. If it's on the outlet side, then as water is being demanded, this little piston will move, and then it will detect that we need to get the pump running. So no issues on the outlet side at all.
Okay. Perfect. Thank you.
Thanks, John.
Thank you. Well, Eric, if there are no other questions, any closing comments?
No, I think we're good. Thank you for your time.
Yeah, I think we're
All right.
good.
No,
Did it.
Thank you, gentlemen.
thank you for setting this up, Derek, and thanks for everyone attending this early before you start your real day.
Thanks, Roberto. Appreciate it. Thanks, everybody.
Thanks, guys. Have a great day.
Thanks once again, and same to everybody.